Alright, in this video I'm going to solve a cubic inequality. Okay, so actually I might solve two. So let's say here's our example. We want to solve 2 times x minus 5, x plus 1, x minus 3, bigger than or equal to 0. Okay, so I want to figure out which values of x make this inequality true. Just like in the quadratic, there's two ways we can do this, by doing the graph or by doing the chart. Doesn't matter which way you're doing it, the first thing you need to do is figure out when this would actually be equal to 0. So let's say we had the polynomial equation 2x minus 5, x plus 1, x minus 3. When does that actually equal to 0? So we look at the corresponding equation if one side is equal to 0. So we know that x minus 5 equals 0, x plus 1 equals 0, and x minus 3 equals 0. Therefore, x is equal to 5, x is equal to negative 1, and x is equal to 3. Let's do the chart first. So let's say you're doing a chart. You're going to, along the top of your chart, set up your intervals. So you're going to go from negative infinity to your smallest x value, or so your smallest 0, which would be negative 1. From negative 1 to your next smallest, which would be 3. From 3 to your next smallest, which is our largest, which is 5. And then from 5 all the way to infinity. So you break up the sort of real number line into intervals partitioned by your x values. Now you're going to write all your factors down. So x minus 5, x plus 1, x minus 3. So now, one thing to notice here is that in this case there was a leading coefficient of 2. Now that's not going to be a problem because if I multiply anything by 2, by any positive number by 2, it's still positive. Any negative number by 2, it's still negative. So 2 won't affect the sign, which is all we really care about. If this were negative, you'd have to put that into your chart to account for that. I'll do an example where that comes up. Actually, you know what? Let's make this an example where that comes up. So I'm going to change the original question. So here I've got a negative. So it's a negative 2. So what I'm going to have to do is, well, I'll put that in at the end. No, I'll put that in. I'll put that in here. So let's say I have a negative 2 above in my chart. So actually, the negative 2 I'll do first. Negative 2 is easy. I made that negative. If this was negative, well then the negative 2 is always going to be negative in any interval. It doesn't matter what x is equal for negative 2. So we always have a negative here. Now look at x minus 5. If x minus 5 is in this interval, pick a number in this interval. Let's say negative 10. So this would be negative, this would be negative, and this would be negative. Right? Negative 10 minus 3, negative. Negative 10 plus 1, negative. Negative 5 minus 5, also negative. Now I'll pick a number between negative 1 and 3. Say 0. Always like 0 if I can. So 0 minus 5 is negative. 0 plus 1 is positive. 0 minus 3 is negative. Pick a number between 3 and 5. Oh, 4 is an easy one. So 4 minus 5, negative. 4 plus 1, positive. 4 minus 3, positive. Between 5 and infinity, let's go with 10. 10 minus 5 is positive. 10 plus 1 is positive. 10 minus 3 is positive. So now we're going to look at the product of negative 2 times x minus 5 times x plus 1 times x minus 3. And worry about the sign. So a negative times a negative times a negative times a negative. 4 negatives. Well, these cancel, or sorry, these make a positive, these make a positive, so overall you have a positive. Even number of negatives makes a positive. 3 negatives, 1 positive, makes a negative. 2 negatives, 2 positives, positive. 1 negative, 3 positives, negative. So going back to the original equation, this was negative, is bigger than or equal to 0. So when is it? So this means positive. Positive or 0. Because it's equal to. So positive, it's positive here, and it's positive here. It's also going to be it's going to be equal 0 right at the intervals, right? That's what we figured out originally. So we're going to have to include x equals 5, x equals negative 1, and x equals 3, because that's what's going to make this equal to 0. So therefore, x is in the intervals from negative infinity to negative 1, but remember we're including negative 1, or from 3 to 5, and we're going to include both 3 and 5. Okay, so we have these two intervals from 3 to 5, from negative infinity to negative 1, but we have square brackets because we're including negative 1, 3, and 5 because we're allowed to be equal to 0. Okay, if you wanted to do this one by sketching, just look at this polynomial equation. Actually, you might find this easier. Plot the x-intercepts. So negative 1, 3, and 5. And it's alright to be very, very rough in the sketch. Now you know the leading coefficient is negative, and it's cubic. So that means you go down to infinity as x gets really large, and down to negative infinity and up to positive infinity in this direction, and it's a cubic, so it looks like this. And now you just want to say, when is x bigger than or equal to 0? It's bigger than or equal to 0 here, it's above the x-axis here, and here. So therefore, x is between, well, can't be square bracket for negative infinity. So round bracket on negative infinity to negative 1. And again, you have to know that you include negative 1 because it could be equal to 0 at negative 1. And then from 3 to 5, and you include both of them because those are your sort of zeros. So same solution as over here. Actually, you might find the graph easier. Yeah, the graph is a pretty easy way to do it for polynomials. The chart, though, will be useful in the future, I promise. Here's another one, just one with a double root, or a order higher than 1 on one of the factors. So let's say it was something like x times x plus 2 squared less than 0. So when is this true? Okay, so if p at x were equal to x times x plus 2 squared, and then that was equal to 0, so what are the zeros? We'd have x equals 0 from that one, and you'd have x plus 2 equals 0, which means x equals negative 2. Actually, I'm going to make this equal to. Okay, so I changed the original question to equal to instead of strictly less than. So less than or equal to. So now you would just plot your two zeros. So one is at 0. One is at negative 2. We have a positive leading coefficient. So that means we go up as we go to infinity and down as we go to negative infinity. And we have, remember, the order of this factor because the exponent is 2. So order 2. So that means at negative 2, you don't cross the x-axis. It looks like just a parabola around that 0. So it hits it, and then that's like the vertex of a parabola. And then goes back up like this. That's a terrible in terms of curves, but it's the general shape. So when is this less than or equal to 2? Well, it's less than or equal to 2 here, here, and actually here also, because that's where it's equal to 2. So really it's less than or equal to 2 for all these values up to 0 and including 0. So x is an element of negative infinity to 0. Okay. If you wanted to do that in a chart, you'd go from negative infinity to negative 2, negative 2 to 0, 0 to infinity. And now when you're writing the factors, one factor is x, another one is x plus 2 squared. Now the good thing about that second factor, x plus 2 squared, that factor's squared. Anything squared, I don't care what x is, it's positive. It's positive, it's positive, because it's squared. So that makes doing this part of the chart very easy. Now we just have to worry about x. Well, if x is in this interval, obviously it's negative, because this interval is negative. This interval is negative 2, so negative, because the factor is just x, and this one's positive. So when we multiply x times x plus 2 squared, we'd have a negative times a positive, which is a negative, negative times a positive, which is a negative, and a positive times a positive, which is positive. We're looking for less than or equal to 0, which is negative. So we get x goes from negative infinity, and now again you might be tempted to say to negative 2, but remember we include x equals negative 2 because x equals negative 2 makes it 0, and we want less than or equal to. So we're going to go include both these intervals. So we're going to go all the way to 0. So it should be a square bracket, because again, same thing I just said. We include 0. So it's the same. So these two are the same. Okay, so just so you see it, an example where the order is 2.